Recently, there's two groups of people that have been talking a lot about L-theanine. First is the biohacker health nut group, including Dr. Huberman himself. They're talking about the anti-stress, even neuroprotective effects of L-theanine. And then you have the tea geeks, the tea heads, the tea cats, right? The tea freaks. And they often talk about how L-theanine brings this savory umami component to the flavor profile of tea. Both of those groups of people are not wrong, and I admittedly am in both of those groups. But there's another side of L-theanine besides the health benefits and the flavor profile that nobody talks about. And I call this the paradox of L-theanine. And it goes like this. The tea plant is the only species of plant on Earth that produces L-theanine. Not only that, but it produces massive quantities of L-theanine. So it's the only one to make this molecule, and it produces tons of it, right? So why? How? But as we're going to talk about today, this is not an accident, and this is not a coincidence. The tea plant produces this molecule in massive quantities for a specific reason. So we're going to break down why the tea plant exactly is creating all of this L-theanine, and then we're going to get to a question that I get asked about more than any other question in relation to L-theanine, and that is, which tea has the most L-theanine? In other words, how is tea processing affecting L-theanine concentration and accumulation in the finished tea product? Because I can tell you that from the moment the tea leaf is removed from the tea plant, theanine levels start changing. And then through the steps of withering, fixing, baking, drying, the theanine levels in tea leaves continue to transform and change. My name is Dylan. I am a PhD tea scientist. If you love tea and want to learn a little bit more about tea, smash that subscribe button, and let's dive into today's video. So let's start by clarifying what is L-theanine, right? Let's take a look at this molecule. So here you see an amine group. Here you see an acidic carboxyl group. You got the acid, you got the amine. That makes it a certified amino acid. But this amino acid is not like others because it does not form proteins. It is a non-protein forming amino acid. So it kind of just floats around as what's called a free amino acid, just by itself doing its thing, floating freely through the tissue and through the sap of the tea plant. And the other interesting thing about L-theanine is just how much of the free amino acid pool it comprises. So for a comparison, let's look at the human profile of free amino acids in the human blood and tissue, right? So here's the pie chart. You see glutamine, glutamate, alanine, a couple of pretty dominant ones, but generally there's a balance. Now look at the tea plant. Upwards of 70% of all of the free amino acids in the tea plant are L-theanine, right? So there must be a reason that the tea plant is investing this much energy into creating this one amino acid. And there absolutely is a reason. So now let's dive into what the theanine molecule is doing for the tea plant that makes the tea plant want to produce that much of it. So the first thing is that the tea leaves get all of the credit for L-theanine, but in reality, theanine is produced in the roots of the tea plant, and then it's shuttled up towards the tea leaves. And the location of theanine synthesis in the tea plant, in the roots, is indicative of what this molecule is doing. So it works like this. Basically, plants like to absorb nitrogen from the soil environment in one of two forms, either ammonium or nitrate. And ammonium has clear advantages over nitrate, mainly that the ammonium molecule stores way more energy and it requires less energy to convert the ammonium into amino acids, right? That's the main reason that the plants want the nitrogen in the first place, is to create amino acids. And the tea plant in particular loves ammonium. Tea plant is a strongly ammonium preferring plant. So that sounds great for the tea plant, right? It gets this really energy rich nitrogen source. But there is also a downside to ammonium, which is that it's toxic and it kills plant cells. This is called ammonium toxicity. The big downside of ammonium uptake is that if you take in too much, you die. So theanine devised this really clever way to take in lots of ammonium and then rapidly convert that ammonium into theanine. So think about it like this. Imagine you're in a field full of gold bricks, all right? But the gold bricks are scalding hot, right? You want to pick them up and collect them, but you can only really hold one at a time because, you got to play hot potato with the scalding hot brick. Now imagine you have a bathtub full of ice water, right? And it's on a wheel, so you can kind of carry it with you through the field. Now you pick up a gold brick, it's hot. You play hot potato for a second, but then you toss it into the bathtub and it goes tss, and then sinks to the bottom, right? So you don't have to hold it anymore. And then you go to the next brick and you kind of do that again and then you throw it into the bathtub. Now you look around the field, everyone else is trying to pick, still play hot potato with one gold brick. Meanwhile, 20 minutes later, you have a bathtub full of gold bricks. while everyone else is still kind of juggling one hot gold brick, right? So that is a metaphor for how the tea plant takes in this otherwise toxic ammonium, rapidly converts it into L-theanine. Rapid conversion of ammonium into L-theanine allows the tea plant to take up massive amounts of this energy-rich ammonium nitrogen that otherwise would be toxic. So it allows the tea plant to accumulate tons of nitrogen, which is really important and really valuable for the tea plant. Now, the tea plant actually, once it converts it into L-theanine, it keeps it as L-theanine, right? That's the preferred storage for nitrogen in the tea plant. It's like, how do you store your assets, right? Do you buy bonds? Do you buy stocks? Do you stuff cash under your mattress, right? Do you invest in Pokemon cards like me? A nice balanced portfolio of Pokemon cards and vintage stamps, right? That's my style. Everyone has their own style, right? For the tea plant, their style of nitrogen storage is the L-theanine molecule. So the last thing about its nitrogen storage function is that the theanine molecule is really lightweight and it's really mobile. It moves 5 times faster than glutamine through the tea plant, right? And a lot of other plants use glutamine as nitrogen storage, but the tea plant devised this clever L-theanine molecule, and that allows the tea plant to move nitrogen through the plant way easier than it would if it had to use glutamine. And that's important, right? Because the theanine is being produced in the roots, but the theanine, the nitrogen, is in highest demand in the leaves, and it's got to go against gravity to get the theanine up there, right? That's not easy. So having a lightweight, mobile form of nitrogen storage is really advantageous to the tea plant. So ammonium detoxification, nitrogen, massive nitrogen accumulation, nitrogen storage, and nitrogen mobility. These are all ways that theanine contributes to the nitrogen efficiency, nitrogen economy of the tea plant. Now there's another huge function of L-theanine, right? This is the second big category of function that L-theanine has in the tea plant, and that is the anti-stress effects. But Dylan, I thought we weren't talking about anti-stress effects today. I thought that was what Huberman and the Biohackers talk about on their channels. All right. Okay, slow down. First of all, calm down. All right. Second of all, I'm not talking about anti-stress to humans. I'm talking about anti-stress to the tea plant. All right. And if you've never heard of plant stress, imagine this. Your feet are rooted in the ground for your whole life. You can't move, right? It gets hot. It gets cold. You have droughts, you have floods, you have insects gnawing at your limbs at all times of the day, right? And you don't even have arms or legs to run away or swat away the insects, right? That is stressful. That is the plant life is a stressful life. And plants have very sophisticated mechanisms to deal with all of these environmental stresses that they face in their everyday lives. Now, remember that all of the nitrogen is stored in theanine. And let's take insect stress, for example. So when the tea plant is getting attacked by an insect, it needs to create all of these new structures and all of these new compounds that repel the insects. And a lot of these structures and compounds require nitrogen. For the tea plant, all of that nitrogen is stored in L-theanine. So the first step of the stress response of the tea plant is that it takes its L-theanine, which is its nitrogen stores, and it sends it right to the zone that is being attacked, right? L-theanine floods that zone. So L-theanine is this crucial mediator of the tea plant's response to plant stress. So take a look at this figure. These are all of the plant stress forms that the tea plant faces, and then the different arrows show how these stresses affect the buildup or the breakdown of L-theanine in the tea plant. So the red arrows are stresses that cause more L-theanine to be created. Blue arrows are stresses that cause L-theanine to be broken down, right? Look at shading. Shading causes a massive buildup of L-theanine, and we know that from teas like Matcha and Gyokuro, which are shaded before they're plucked in an effort to build up these L-theanine levels to create more of an umami tea. Now look at high temperature stress. Through various different mechanisms, this stress form breaks L-theanine down because the L-theanine is basically the currency of nitrogen that the tea plant has. So L-theanine, in order to respond to this high temperature stress, it needs to start breaking down its L-theanine currency, its nitrogen currency, so that it can use these building blocks to create other new things to help protect it from this high temperature stress, right? And this gives you a look at why a summer tea has less L-theanine than a spring tea, because in summer you have high heat, you have high UVE radiation, you have insect pressures at its highest. Right? So all these stress forms cause the tea plant to continually be burning through its stock of L-theanine in order to create these self-defense structures. As much as I would like to think that the purpose of L-theanine is to make me go, yum. The theanine molecule actually has more important things to do, and that is protecting the tea plant from stress and from environmental damage. So speaking of flavor quality and speaking of the human, now we're reintroducing the human into this picture. It's not just between the theanine molecule and the tea plant anymore. Now let's talk about tea processing. The first thing about tea processing and L-theanine is that the moment that the tea leaf is removed from the tea plant, L-theanine levels can only go down, right? Because L-theanine, as we mentioned, is being produced in the root of the tea plant. And now once this is removed from its L-theanine source, L-theanine levels can only go down. So then once processing starts, let's go with withering. That's usually the next step for a lot of tea types. So withering in the mind of the tea plant is basically just a gigantic drought stress, right? Because the tea leaf has been cut off from its source of water and its nutrients. The tea plant is kind of freaking out. All of these enzymatic activities that mediate plant stress get kicked into gear. And that includes those enzymes that break down L-theanine, right? So that the building blocks can be used to create other structures. This enzyme is called theanine hydrolase, right? It induces the hydrolysis of theanine, the breakdown of theanine. So these enzymes get kicked into gear during withering. So as long as enzymatic activity is happening, such as withering, bruising, and the oxidation steps of teas like oolong and black tea, L-theanine levels are going to continue to go down. Conversely, take a tea like green tea. What is the first step of green tea? It's fixing. It is denaturing the enzymes in the tea leaf. So that step stops the enzymatic breakdown of L-theanine, right? So now if you're looking at which teas have the most L-theanine, green tea and yellow tea, which both are teas that start with a fixing step, are the teas that have the most L-theanine. And they usually can preserve about 95% of the theanine that's in the original leaf, right? So that's tier 1 of L-theanine concentration. The next tier down is oolong and black tea, right? Because these have, like I said, those long withering and oxidation steps. There's a lot of enzymatic activity. So L-theanine in those teas drop to about 70 to 80% of what was in the original leaf. The next tier down is white tea, right? Because white tea, a lot of people say that's the most minimally processed because it has the least number of steps, but it has one long step, which is a 2-day withering process, which actually triggers more enzymatic activity than oolong tea or black tea. So that's tier 3, and it usually only preserves about 50 to 60% of the original L-theanine that's in the fresh leaf. The lowest group on the L-theanine totem pole is the dark tea, right? Because this goes through heavy microbial fermentation, and it depends on the dark tea, right? Because as we've talked about before, you have ripe pu-erh and you have raw pu-erh, and those are totally different teas. They shouldn't even belong in the same category, but unfortunately they do, which is confusing for everybody. But if you're looking at a raw tea, that's closer to green tea. You know, you might preserve theanine levels around 30% in that. But if you have a ripe pu-erh, which has been fermented microbially for 2 months, you know, theanine levels in a ripe pu-erh are close to below 5%. So basically non-existent. So that is the enzymatic side of what happens to theanine. But during processing, there's other really cool things that are happening. And there's 2 of them in general. The first one is that theanine serves as a precursor for Maillard reactions. A Maillard reaction is when you take an amino acid and you take a sugar and you add heat. Bring them together and it creates this really sweet, delicious, savory aroma, right? And that's what you get from the drying and baking phase of oolong tea and black tea production, right? That's why the aromas in oolong tea and black tea have these like way more of a mouth-watering, savory aroma as opposed to a green tea, which is much more of a vegetal kind of grassy, and it doesn't really make you hungry. So with the Maillard compounds, you are losing theanine, but it's for a good cause because you get the formation of these amazing mouth-watering aromas. Now, there's a second pathway for L-theanine when it disappears during tea processing, and that is the theanine molecule can actually fuse and combine with catechins and other polyphenols and other molecules in the tea leaf. And it creates a huge array of new compounds that don't even exist in the fresh tea leaf, right? They're only produced through these unique steps of tea processing. And one cool example is this molecule called Flavoalkaloids. It's a class of molecules that was only discovered in the last couple of years, so there's not that much research about it, but it's most abundant in dark tea. That's the tea type, as we just said, that has the least L-theanine. And that's because as L-theanine drops and goes away, it literally is used to create these new molecules. So as you lose L-theanine, you gain unique new compounds such as flavoalkaloids. And we don't know much about this molecule, so I don't want to speculate, but one study said pound for pound, these flavoalkaloids have stronger anti-senescent effects than the theanine molecule itself. It just goes to show that when you lose theanine throughout tea processing, it doesn't necessarily make the tea less healthy or less good, right? Oftentimes, as you're losing theanine, it's combining with catechins and other polyphenols to form these other really unique compounds that we don't even really understand yet. But initial studies are looking like they are also very healthy too. Okay, so let's recap some of these cool tidbits about L-theanine. L-theanine is the preferred nitrogen storage, nitrogen mobility, and ammonium detoxification pathway for the tea plant, right? The tea plant stores its nitrogen cache as theanine. And having stored its nitrogen as theanine, when it comes to plant defense, theanine is the first on the scene to protect the tea plant because the tea plant needs this nitrogen to build new self-defense, plant stress defense structures, right? And so that's the reason why in high heat and high UV conditions like summer, you have less theanine in the tea plant because this molecule is being shuttled to the leaves and used for other purposes. Next, in terms of the processing of tea, the longer the enzymatic activity is allowed to go on, the less L-theanine you get. Green tea and yellow teas with that initial fixing step preserve a lot of the L-theanine by breaking down and denaturing L-theanine hydrolase. But with the other tea types, oolong, black tea, white tea, you are losing theanine, but these theanine molecules are going to a good cause, right? They're creating Maillard compounds to increase and enhance the aroma of the tea. And they're also being merged with other catechins to create these brand new, unique, lesser known molecules such as flavoalkaloids, which may be just as beneficial as theanine itself. These were a couple topics that really I've never heard talked about on YouTube before, but if you want to understand theanine, which is really an incredible molecule, it's not just about what the theanine molecule provides to us, right? It's not just, the story is incomplete if you're just talking about what it does for me as the human consumer, right? Because the tea plant produces L-theanine not for human consumption, it produces it for itself, and it has these massive important functions in the tea plant. And that's the other half of the story that nobody really talks about, but is equally as important as these health benefits and these flavor benefits that we get from L-theanine. And if you do want to understand more about the health benefits, that's great. That's an interesting topic too. And I have this video for you right here. It's about green tea in general, but there's a whole section just about L-theanine. And then if you want to dive deeper into the whole world of tea, then as always, I'm putting chapter 1 of the 8 video masterclass on tea for you right here. That is an awesome resource for you. As always, stay healthy, stay positive, and keep sipping tea. Love.